Alexandrite is one of the rarest and most valuable gems in the world. It was coveted by czars and possesses the most dramatic of optical effects, changing its color from an emerald green to a ruby red. But how did Mother Nature create this magical stone, and where is it found today? Let's start with the Earth's very own gemstone superstore, also called a pegmatite. About 250 million years ago, when the Earth's major landmasses were still a single supercontinent known as Pangaea, high temperature and pressure from the outer layers of our mantle forced magma to the surface. And as this magma rose, it cooled and began to crystallize. Low concentrations of water were pushed aside and built up in the rest of the magma. As common minerals like quartz and feldspar began to form, rare elements that weren't as easily incorporated into these were also left out. The result was a highly mobile fluid filled with rare element ions that mixed and matched. Think of it as the ultimate primordial meet and greet. This fluid finally became so abundant that it separated into pockets and solidified in cracks and crevices to form a pegmatite. These were a total gem bonanza, producing a wider range of minerals than any other rock type ever. They can also contain some of the largest crystals we've ever mined. I'm talking gems like tourmaline, topaz, garnet, zircon, beryl, and, if you're especially lucky, alexandrite. Alexandrite is a variety of the mineral chrysoberyl, and it's colored by chromium. You see, this process of magma moving through the earth and mixing up elements sometimes resulted in a very special meet-cute between two rare and distinctly different elements, namely beryllium and chromium. And that chromium is the key to alexandrite's most important property, color change. How does it work? Well, this is a bit of an info dump, but trust me, it's totally worth it. Visible light is made up of all colors in the electromagnetic spectrum. If all of this light were to pass through a gem all at once, it would appear colorless. One important way gems get their color is by absorbing certain wavelengths of this light while letting other wavelengths continue on their merry way. Kind of like an electromagnetic troll bridge. Often, the elements responsible for this process of absorption and transmission aren't actually part of the mineral's base chemical composition, but are instead what we call trace elements or impurities. Emerald, ruby, and alexandrite all owe their color to one trace element, chromium, specifically the chromium 3+ ion. Why does the same ion result in such different colors? Well, that's actually a bit of a trick. The absorption of light in all three of these gems is actually really similar, with only slight differences owing to the positioning of the chromium atoms in the atomic structure. In a ruby, there are two transmission windows of light that are allowed to pass through. One is centered around 480 nanometers, which is the blue portion of the spectrum, while the other is above 610 nanometers, which is in the red. But since our eyes are more sensitive to the red, that's what we see. Emerald's transmission windows are shifted just a bit so that its first window is centered in the green, where the eye is most sensitive. So we see green. But alexandrite's first transmission window manages to be right in between these two. So much so that a simple change of light is enough to tip the scales, so to speak, between the red and green. Daylight's maximum intensity is in the blue-green part of the spectrum. So in daylight, alexandrite appears blue to green. But in incandescent and candlelight, where a larger portion of the light is in the red spectrum, it appears red or purple. It's kind of like a Gemmological T1000 adapting to its surroundings. It's been called emerald by day, ruby by night. Pretty neat. Discovered less than 200 years ago, it's practically a baby compared to other precious gems whose histories stretch back to ancient times. It was first found in 1833 amongst the many famous gem deposits of Russia's Ural Mountains. A mine manager named Yakov Kokovin came across this peculiar green stone with a higher hardness than the surrounding emeralds. He passed his samples along to his superior, Count Lev Alexeyevich von Perovsky, who shared them with a colleague, Niels Nordenskjold. It's unclear who first discovered the all-important color change property, but Nordenskjold would later write that there is no mineral with such a distinct phenomenon, and that it deserves the first rank among gemstones. This new gem was originally dubbed diaphanite, but sensing a political opportunity, Perovsky renamed it in honor of the future Tsar. The ploy worked, and Perovsky soon became Minister of the Appanage Department, overseeing the imperial estates, property, and investments. So what happened to Kokovin? Well, a few years after his discovery, Perovsky accused him of stealing several gems, including a unique emerald. He was imprisoned and died soon after. Years later, after Perovsky's death, the emerald was found in Perovsky's own personal collection. Yikes. Gemology can be downright vicious sometimes. Alexandrite itself became all the rage amongst Russian nobility, who set the bling standards for the rest of the world. Alexandrite was soon prized in the salons of Paris and London, while it was sold by Tiffany around the world. Unfortunately, this meant that before the end of the 19th century, the original source was all mined out. And for much of the 20th century, Alexandrite was only found in scant amounts of varying quality around the world. But in 1987, a major strike of Alexandrite was made at the Hematita mine in Brazil. The result was a brief Alexandrite rush that quickly turned violent and required the government to build a moat around the mine. Since then, small deposits of Alexandrite have also been mined in places like Africa, India, and Sri Lanka. Few of these rival the original Russian finds, though the very best Brazilian stones feature the highest concentration of chromium and are thought to exhibit the finest color change. While it definitely remains a very scarce gem, it has even been found in America. The Alexandrites from the Madeira mine in New Mexico are often smaller pieces with weaker color change properties. But still, how cool would it be to find something like this in your own backyard? Tell me, which gem's origin would you like us to feature next? Let me know down in the comments, and while you're there, like, subscribe, and ring that bell so you don't miss out. See you next time!